Welcome to notes 3.6 and 3.4. We are going to begin by talking about perpendicular lines. All right, so we have a little definition kind of here, distance from a point to a line. The distance from a point to a line is always the perpendicular distance from the point to the line. Perpendicular distance because it's the shortest distance from the point to the line. All right, so let's talk. If we've got two lines and they intersect to form a linear pair of congruent angles, then the lines must be perpendicular, all right? Because if these two guys are congruent and they're a linear pair, their sum is 180. If they're congruent, they're each half of 180, so they're each 90, which means that we must have a linear pair going on here. So, I'm sorry, perpendicular lines. Which means that if angle 1 is congruent to angle 2, then line G is perpendicular to line H. All right, and then related to that is if we have two lines that are perpendicular, then they intersect to form 4 right angles. So if A is perpendicular to B here, then angle 1, angle 2, angle 3, and angle 4 are all right angles. Are 90 degrees. Moving on. All right. If we are given that angle 1 is congruent to angle 2, what do we know about lines A and B? Well, they're a linear pair, they're congruent, therefore we know that A is perpendicular to B. All right, and then if we have two sides of two adjacent acute angles are perpendicular, so if this is perpendicular to this, which it is because we're shown that in the diagram, and these are adjacent acute angles, then the angles must be, what goes in the blank? Complementary. So if BA is perpendicular to BC, then angle 1 and angle 2 are complementary. They each, together, their sums are 90 degrees. All right. And then we are given that angle 1 is congruent to angle 2, and we need to prove that 3 and 4 are complementary. I don't think we have enough space here. Let me see if I can move some stuff around and make some space. Hang on a second. All right, that's better. Okay, so we are given that angle 1 is congruent to angle 2. Given. And we need to prove that 3 and 4 are complementary. Well, how about if we're given a pair of, a linear pair that is congruent, then we know that these two lines must be perpendicular. So we know that QV is perpendicular to PS. Okay, and then the reason why we know that is because if two lines form congruent linear pair, then it is perpendicular. All right, that's kind of the shorthand way of saying what we learned on the previous page. All right, so that means if these two lines are perpendicular, that means that this is a right angle. So we can say angle QPS is a right angle. How do we know that? Well, that's the definition of perpendicular lines, that they meet at a right angle. So you know what, now that I'm thinking about it, we didn't even really need to say that. I was going to get kind of complicated and I was going to say that this is a right angle, these two together equal a right angle, therefore they're complementary. But actually, this theorem up here that we just talked about, we can go straight from these are perpendicular, therefore these are complementary. So we can say that angle 3 is complementary to angle 4, and our reason is if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So this step right here is sort of superfluous, so perhaps I shouldn't have written that. Oh well, sometimes you get into proofs and you start thinking, I don't really need that, but as long as it's not wrong, you can leave it and you'll be okay. All right, we've got a couple more theorems we're going to talk about here. And the perpendicular transversal theorem says that if I have a transversal and is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So in this drawing over here, if H is parallel to K and J is perpendicular to H, then J is also perpendicular to K. And then if I have lines perpendicular to a transversal, theorem states in a plane, and this is very important because we've already shown that if those words aren't there, then this particular theorem is not true. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to P and N is perpendicular to P, then M is parallel to N. Only in a plane. Those words are very important. All right, sorry, I had to do some rearranging there. Okay, this diagram here asks us this question: is C parallel to D? And then tells us to explain. Well, is C parallel to D? Yes, it is. And that is because we've got A is perpendicular to C, and we've got A is perpendicular to D, and we have just shown previously that two lines perpendicular to the same line are parallel to each other. All right, and then we need to know if B is perpendicular to D here. So I want you to think about that and think about what your explanation would be, and we will talk about that in our notes check. And our question here asks, what is the exact and approximate distance from line M to line N? So they've kind of shown us what they want us to use. They want us to use this point right here and this point right here. And distance means that we are going to be doing the distance formula. Yay! So our distance formula, which you'll remember because you've got it memorized at this point, is the square root of the difference of the x's, so x2 minus x1 squared, plus the difference of the y's squared, so y2 minus y1 squared. And then we've got these words exact and approximate. And you remember that exact means don't round, and approximate means that we go ahead and round. So let's go ahead and see if we can't find this. All right, so we're going to go ahead and use these 2 points right here, 1, 2, and negative 2, 3, to find the distance. So I go ahead and plug in the x's. So I'm going to do 1 minus a minus 2 squared. And then I'm going to do the y's. So 2 minus 3 squared. All right, so that gets me the square root of 1 minus minus 2 is 3. So I get 3 squared plus negative 1 squared, which means that I get, 9 plus 1. So I get the square root of 10. All right, can I take the square root of 10 without rounding? No, I cannot. So this is my exact answer. Then I go ahead and I plug it into my calculator, and I'm going to get my approximate answer. That gives me approximately, 3.2 units. We good? Excellent. All right, let's talk a bit about slope. So slope, if we were to put it into words, we would call it rise over run. Okay, it's the amount we go up on a graph versus the amount up or down versus the amount we go horizontally. We use M to represent slope in formulas. And you may have also seen it delta y over delta x. This delta means change, so we're talking about the change in y over the change in x, which leads us to our formula, which is the change in y, so y2 minus y1 over the change in x, which is x2 minus x1. So since all you guys have had Algebra 1, you should have this formula memorized, no problem. Another way you might hear slope referred to, just to kind of bring back some golden oldies, is rate of change. Okay, particularly in word problems, you'll see rate of change a lot. All right, let's talk about the slope of lines. So there are 4 kinds of slope: negative, positive, undefined, and zero. And a negative slope is a slope that falls from left to right. So line J here, get out my highlighter because I love highlighting stuff. So line J goes down from left to right, it falls from left to right. All right, and then a positive slope rises from left to right. So line K has my positive slope. All right, and then we have the ones, those are pretty easy, right? A negative and positive slope, you guys get those. But undefined and zero are the two that confuse us. So an undefined slope is the slope of a vertical line. All right, it is the straight up and down one, as in line N here. And a zero slope is a slope that goes nowhere. So the slope of zero is a slope for horizontal lines. And these two I like to think of, if I stand on a horizontal slope and I take a step, I go nowhere, I go zero. But if I stand on a vertical slope and I take a step, I fall off and plummet to my death because I just keep on dropping down forever. And so that's one way you can think of vertical and horizontal lines. A little macabre, but you know, it works. All right, so when we're talking about slope, we need to talk about the slopes of parallel lines and perpendicular lines. And so in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And I want you to be thinking about why we made this little criteria, two non-vertical lines. And we will discuss that at a later point. All right, and then perpendicular lines in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. And the way I like to think about it more than the product of the slopes is -1 is that they are negative reciprocals or opposite reciprocals. So for example, if one line, let's say this one, has a slope of 1/3, positive 1/3, then this line right here would have a slope of -3/1. The signs are opposites and they are reciprocals of each other, so they are flipped. And if I were to multiply these two together, I would in fact get -1. But that is our perpendicular line. So parallel lines, same slope, perpendicular lines, opposite reciprocal slope. All right, I would like you to find the slopes of these lines. So we need the slope of line A, the slope of line B, the slope of line C, and the slope of line D using the given points. And then come back when you've got them and check and see if you're right. So please hit pause now. Okay, so I realize that you could just get these slopes by counting, but I went ahead and used the slope formula anyway so you could see what's going on here. So A had a slope of 1. B had a slope of -1, so these two are perpendicular to each other. And then C was a horizontal line, so it had a slope of 0. D was a vertical line, so it had a slope of undefined. And you can see that when I do the slope formula for the 0 slope one, I got 0 on top, and that gave me 0. And for the undefined slope, I got 0 on the bottom because nobody can divide by 0. Except for Chuck Norris, and so that gets me undefined. And these two are also perpendicular to each other, even though their slopes are not opposite reciprocals. So food for thought there. And in this case, we are going to use slope to determine which of the lines are parallel. So what I need you to do for me is I need you to find the slope of K1, and I need you to find the slope of K2, and then the slope of K3. And once you've done that, come back and tell me which ones are parallel. So hit pause now, please. All right, so if you counted, that's fine. But it would have been nice to use the slope formula just to kind of practice it and make sure that you know what you're doing with it. And you should have found that the slope of K1 was 5, the slope of K2 was 6, and the slope of K3 was 5, which means that K1 is parallel to K3 because they have the same slope. All right, so here we're given that line K passes through the point 1, -2, so 1, -2, and 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so there is my line, and let's make it that color. All right, so it goes through these 2 points. Okay, and we need to graph a line that is perpendicular to K here. Make it a line with some arrows. And it needs to pass through the point 2, 5. So 2, 1, 2, 3, 4, 5. All right. So I could just kind of try and eyeball it, but we need to be absolutely certain. And the thing that we know is that we know that perpendicular lines have opposite reciprocal slopes. So if I were to find the slope of line K, and I can do that basically by counting. Let's use the 2 points because I'm not feeling super confident about this line that I drew. So it is a rise of 1, 2, 3, 4, 5, 6, 7, 8, and a run of 1, 2, 3, 4. So 8 over 4, also known as 2, which means that the slope of my perpendicular line should be, just write perpendicular here, a negative 1/2, opposite reciprocal, right? So I flipped it and I changed the sign. So from my point here, I can go down 1, right 2, down 1, right 2, and that will help me draw my perpendicular line. So there you go. So doesn't ask us to write an equation, so we're not going to go and do anything that we don't have to do. We're just going to graph. And that's what we did. Through this point, perpendicular, and we know it's perpendicular because it has opposite reciprocal slope. All right, we're given a couple situations here with some lines, and we need to tell whether the lines are parallel, perpendicular, or neither. Well, in order to do that, we need to know what their slopes are. So I need you to find me the slopes of line B and line E, and then you are going to tell me whether the lines are parallel, perpendicular, or neither. Same thing down here. Slope of line A and the slope of line B, and tell me parallel, perpendicular, or neither, and then come back and check your answers. So hit pause, please. All right, so when you find the slope of line B, you should have gotten 3, and the slope of line E was negative 3. 3 and negative 3 are neither the same, nor are they opposite reciprocals, so these would be neither. Down here, we got the slope of line A was negative 2/7, and the slope of line B was 7/2. These are opposite reciprocals, therefore they are perpendicular. If you had any problems with that, please make sure you ask about them in class. And that concludes our notes. Thanks.